This is the TI evaluation board which is used in our project. The microcontroller used here is MSP 430 FG478. Among other components of TI, we used a voltage regulator and a 5x5 timer. Now I am going to explain the circuits which are used in our project. This is the circuit to control motors, heaters and boilers inside the greenhouse. These are the relays which are being used to turn on these AC components inside our greenhouses, and these are the L29 3Ds which are used to turn on these relays. These L29 3Ds are directly interfaced with our microcontroller. This is the sensor part of our project. This humidity sensor will be placed inside the greenhouse. This is the 5x5 timer from TI which are used to generate 1 kHz square waves which are sent to this humidity sensor. This humidity sensor acts as a potential divider for this square wave, which is then being rectified with the help of precision rectifier which is being built around this op-amp. This is the motor driver, that is L29 3D, which are used to control the stepper motors, to control the angle of the vents. The vents is used for controlling the temperature. The temperature inside the greenhouse is sensed with the help of LM35 temperature sensors. There are two temperature sensors visible over here. One of them will be placed inside the greenhouse, while one is placed on the breadboard itself to sense the temperature outside the greenhouse. This is the model of the greenhouse which is built for our project. Our project targets the control of the environment inside this greenhouse. We are going to control 3 parameters, that is the temperature, air humidity and soil humidity inside this greenhouse. To control the temperature, there are 2 vents on this greenhouse. The angle of these vents are controlled by stepper motors. There is a fan installed inside the greenhouse to aid the ventilation inside it. There is also a temperature sensor inside the greenhouse to measure the temperature inside the greenhouse. To raise the temperature inside the greenhouse, we use a heater which is built by us, which is controlled through a DC power and is connected to the microcontroller through a relay interface. We control humidity inside the greenhouse with the help of a boiler, and we sense the humidity with the help of a humidity sensor. To control the humidity in the soil, we use a soil sensor which is based on the resistance of the soil. We use a water pump which is also interfaced to microcontroller through a relay to water the plants inside the greenhouse. The help of fitness function which is described in the reference paper used by our project. Now we are going to demonstrate the temperature control of our project. These are the windows of this greenhouse controlled by the stepper motors. Now the system will try to reduce the temperature of the greenhouse and try to maintain inside temperature to the outside temperature. Right now the temperature of inside of the greenhouse is 28 degrees Celsius as shown by the temperature sensor inside the greenhouse. Now the algorithm will try to reduce the inside temperature by opening the flaps and turning on the fan. Now the algorithm is trying to reduce the temperature of the greenhouse by opening the vents so that air ventilation can take place. There is a fan installed inside the greenhouse to aid the air ventilation, which is now. As the temperature inside the greenhouse is decreasing, the angle needed for the air ventilation is reducing, and hence the vents has been turned down by the algorithm. As the temperature reaches the optimum value, the vents has been closed. Now we are going to demonstrate how our project will handle the control of humidity inside the greenhouse. This is the humidity sensor, which has been interfaced with the microcontroller through an ADC. The voltage reading at the moment is 0.37 volt. The target potential level of the humidity sensor as given by the parameters is 0.48. This is the boiler which has been controlled by the microcontroller. As the microcontroller senses the humidity level is not at the optimum level, it turns out the boiler so that it can generate water vapors inside the greenhouse. The vapors generated by the boiler is sensed by the humidity sensor, and the algorithm senses the level of the humidity inside the greenhouse. The humidity now has reached 0.4 volt inside the greenhouse. Now, as the humidity potential levels have reached within the minimum thresholds of the requirement, the boiler has now been turned off. Now we are going to explain how we are going to water the plants inside our greenhouse. This is a soil humidity sensor which is based on a potential divider. It senses the resistance of the soil depending on the water inside it. At the moment, the potential divider is at 0.79 volts, which will decrease as we are going to water the plant. The water will be poured inside the greenhouse through a motor which is submerged inside water. This motor is going to be turned on with the help of the relay, which is interfaced to the microcontroller through a motor driver called L293D. Now, as the microcontroller has sensed that it needs to water the plant, it has turned on the motor. Now, as the potential of the sensor reaches the optimum level, the microcontroller senses the humidity inside the soil and it turns off the motor.